Yes, let's report. Okay, perfect. All right, so again, guys, please let me know if you have any specific question or request about the first test or second test. Just let me know. So this is problem number 5. And the second test number 2. So what does it say? The problem, it says that you have to prove that the equation x to the power, so prove that x to the power 11 plus x fifth plus 4x minus 2 equal to 0. So we have to prove that this equation, so that the equation has exactly, so the key word I would say here is the word exactly. So has exactly one solution. Okay, so this is exactly one solution. All right. So so to answer this question, actually there are 2 steps. So first step, in step number 1, we have to use the intermediate value theorem to show that the equation has at least one solution. Okay, so step 1, we have to use the IVT, the intermediate value theorem. Okay, this is IVT, that's the intermediate value theorem, to prove or to show that the equation has at least the equation has at least one solution. So when you say at least, guys, it means it could be one solution or it could be more than one, right? It could be 1 or 2 or 3, etc. So it could be 1 or more than 1, right? And that's not exactly, this doesn't answer our question here, right? Because the problem, in the problem, we have to prove that the equation has exactly one solution. So in this first step, you don't say that the equation has exactly one solution. In the first step, you are saying that the equation has at least one solution. So it could be 1, 2, or more, right? So so that's not, step 1 is not enough to answer this question, right? But anyway, so how do we do this first step? Well, we have to use the intermediate value theorem. So how do we use this intermediate value theorem? Well, the idea of the intermediate value theorem is the following. If your function f has 2 values with opposite sign, all right, like a positive value and a negative value, then it means that your function f, to go from positive to negative or to go from negative to positive, you have to cross the x-axis. So then it means that your function f is going to have at least one solution, right? So so what we do here, we pick numbers such that the values of the function, so the function here, of course, f of x, so f of x would be our equation here. So that's x 11th plus x 5th plus 4x minus 2, right? So if you pick, let's say, just to pick very simple numbers, okay? You don't have to think about it a lot, right? So just pick, for example, 0. So if you pick 0 and you evaluate f of 0, well, if it's 0 to the power 11, 0 to the power 5 plus 4 times 0. So everything is 0 except the minus 2. So f of 0 is negative 2, right? So here, what I'm saying is I have some a negative value of the function f, right? F of 0 is negative 2, so that's a negative value, right? Now, I'm going to pick another number, okay? And says that the value of the function at that number would be positive. So if you pick, let's say, again, just pick some random numbers, and most of the time you can just pick 0 or 1 or 2. You don't have to pick like a very large number. Just pick very small numbers like 0, 1, 2. So if you pick 1, for example, then it's 1 to the power 11 plus 1 to the power 5 plus 4 times 1 minus 2. So that's 1 plus 1 plus 4 minus 2. So that'll be equal to 4, positive 4. So you see, f of 1 is positive 4. F of 0 is negative 2, right? So what we are saying here, guys, is that, so, I mean, if you think about it, you know, you have, this is, let's say, x-axis, this is y-axis, and what you are saying is that this is negative 2, here's positive 4, this is 0, and this is, let's say, 1. And so what we are saying is that, you know, f of 0 is negative 2, f of 1 is positive 4, right? Now, you have to go from, you have this function, which is continuous function. So you have to go from negative 2 to positive 4. So then you have to cross the x-axis, right? Here. And if you cross the x-axis, it means that there exists this number, let's say this number c. You don't know exactly the number c, but there exists a number c in this interval 0, 1, says that f of c is actually 0. So that will be a solution, you know, of your equation. So now conclusion is that by the IVT, the intermediate value theorem. So by the IVT, there exists a C there exists C says that f of c is 0. Okay, so
Professor,
yes,
is that f of c or f prime of c?
no, f of c. So here I'm talking about the IVT. So the IVT, I don't really use the derivative. This is f of c. So here the IVT in this first step, all we're saying is that there exists at least one solution. So this c would be solution of f of x equal to 0. So then they exist, you know, f of c. So then c would be a solution of f of x equal to 0. So then we have at least one solution of f of x equal to 0. Right? Now, the thing is, you know, you're gonna go from negative 2 to positive 4. You could cross the x-axis more than one time, right? So, for example, I mean, it's possible that your graph would be like, you know, you wanna go from this negative 2 to positive 4, but then you can go like, you can cross x-axis first time, a second time, a third time, right? So you would have more than once. You could have more than one. Solution of f of x equal to 0, right? So this first step is just say that there is at least one solution. It could be 1, it could be 2, it could be 3, it could be more, right? But you know there is at least one solution, right? Now, in the second step, so we know that there is at least one solution. Now, in the second step, we're going to prove that there is no more than one. So step 2, in the step 2, so we're going to prove that there is no more than one solution. And here, to prove that there is no more than some number of solutions, you have to use the Rolle's theorem. There is no more than one solution, and so we have to use Rolle's theorem. So when you say, guys, no more than one solution, it means it could be 0. You could have no solution, 0 solution, or 1 solution, right? But then you see now later when you can combine the first step and the second step. So the first step, so on one hand you're saying, well, there is at least one solution. So you could have 1 or 2 or more solutions. And on the other hand, the second step, you are saying there is no more than 1. It could be 0 or it could be 1. So what would be the intersection of the two steps? So if you combine the two steps, then you can deduce that there is exactly one solution, right? Because on one hand, you have no more than one solution, and on the other hand, there is at least one solution. So when you combine the two statements, right, you can deduce that there is exactly one solution, right? Now, how do we use the Rolle's theorem to prove that there is no more than one? There is no more than one. Well, we're going to use a proof by contradiction. So use proof by contradiction. Okay, so here we're interested in, so we want to prove that there's no more than one, right? No more than one. So I'm going to suppose I have two. That's more than one, of course, right? I'm going to suppose I have two solutions, and then I'm going to end up with some contradiction. And if I end up with a contradiction, it means my hypothesis is wrong. So it means that I cannot have two different solutions. So if you cannot have two different solutions, it means that you have no more than one, right? So I'm going to use proof by contradiction. So I'm going to suppose, so my hypothesis, so I'm going to suppose I have two different solutions. Suppose we have two different solutions, A and B, two different solutions, A and B. Okay. So when I say solution, I mean f of x equal to 0, right? So solution of f of x equal to 0. So f of A is equal to 0, and f of B is also equal to 0, right? A and B are supposed to be solutions of f of x equal to 0, right? So I have these two solutions, A and B. So both are equal to 0 because both are solutions of f of x equal to 0. So what does it say, the Rolle's theorem? Well, it says Rolle's theorem says that if you have f of A is equal to f of B equal to 0, so then by Rolle's theorem, so if you have f of A equal to f of B, then by Rolle's theorem there exists C in the interval AB such that f prime of C is equal to 0. So this is what actually you're asking. We were asking Daniel. So here in this second step, my C would satisfy f prime of C is equal to 0. Okay. So Rolle's theorem, it says that whenever you have f of A equal to f of B, then there will be a C in this interval AB, says that the derivative of f at C is 0, right? So that's the consequence of the Rolle's theorem. Now, where's the contradiction? Well, the contradiction is the following. So now we are saying that there is a solution of the derivative equal to 0, right? But what's the derivative of f? So on the other hand, so if you compute f prime of x, so on the other hand, so if we solve f prime of x equal to 0, so what's f prime of x? Well, so it's x to the power 11, derivative of x power 11, that would be x 11, x to the power 10, right? Plus x fifth derivative, that would be 5x fourth, plus 4x, so it's plus 4 times 1, minus a derivative of constant 2 is just 0, so that's a 0 equal to 0. So this is my f prime of x, right? So on the other hand, if you try to solve f prime of x equal to 0, well, and you try to find the solutions of f prime of x equal to 0, well, the thing is, you see here, this is x to the power 10, So if you have, because 10 is even, right? 10 is even, this power 10 is even, this power 4 is also even. So because you have even powers, then x to the power 10 or x to the power 4, they have to be positive or zero. They cannot be negative. So this thing here, this is positive or zero, of course, if x is zero. This is also positive, you know, x fourth, because the power is even. So if you have x, if x is negative, -1, let's say, then -1/4, there'll be -1 times -1 4 times, there'll be +1, right? So if you have x fourth, then it's always positive, or zero if x is zero, of course. So it's positive or zero. And then +4. The +4, of course, that's a positive number, right? 4 is a +4 is positive. So you see, guys, we have a sum of positive numbers. And the sum of positive numbers, it must be positive, right? You have positive or zero, plus positive or zero, or plus positive. So the whole thing, the whole thing must be positive. It cannot be zero. So the sum here, this whole sum, so the sum of positive numbers must be is positive. So f prime of x cannot be zero. So there is no solution. So it cannot be zero, right? So because it's a positive, so equal to zero, there is no solution to f prime of x equal to zero, right? So we are saying if we take if you take a look to the derivative equal to zero, then actually it turns out that there is no solution to the derivative equal to zero, right? And this is a contradiction with the Rolle's theorem, because Rolle's theorem, remember our Rolle's theorem says that, well, there exists a C. There's a C here in this interval A. B says that f prime of C is zero. So we are saying that there exists a solution of the derivative equal to zero. But here, when we analyze the derivative equal to zero, well, it turns out it cannot be zero. It's positive. My derivative is always positive for any number x. If you pick any real number x, the derivative is going to be positive. So it cannot be zero. So there is no solution. So it's a contradiction with the Rolle's theorem. So if you have a contradiction, of course, it means that your hypothesis is wrong. So this hypothesis, this one here, suppose we have two different solutions, it's wrong. You cannot have two different solutions. So if you cannot have two different solutions, it means that you have no more than one, right? So either one or zero. So no more than one solution. So the conclusion here, and this is step 2, contradiction with the Rolle's theorem. Okay, so there is no more than one solution. There is no more. So the hypothesis is wrong, and so there is no more than one solution. Okay. So what we are saying, guys, is that in the first step, we said we have at least one solution. Okay, at least one. Could be one, it could be more. And the second step, that we are saying there is no more than one, right? There is no more than one. So if it's at least one and at the same time no more than one, so then the only option is that we have exactly one solution, right? So conclusion, we have exactly conclusion. So step 1 plus step 2, they imply there exists exactly one solution. Right? Does it make sense to you guys? Any question about this? So that's yeah. So that's the answer for problem number 5. So there's a difference between actually between the problem number 5 and number 6. So in number 5, we have to prove that there is exactly one solution. So when you have to prove that there is exactly one solution, so then there are two steps. You have to use the first IVT to say, well, there is at least one, and then Rolle's theorem as second step. Use the Rolle's theorem to say, well, there is no more than one, right? And so you combine the two to say, well, there is exactly one. Now, in the problem number 6, you have to prove, in the problem number 6, in the second test, you have to prove that there is at most two solutions, real solutions, right? At most two, or no more than two solutions. So no more than some number of solutions. So then you have to use the Rolle's theorem. So you don't need the IVT, because if you use IVT when you have to prove that there is at least one solution. But the Rolle's theorem, if you use the Rolle's theorem, you prove that there is no more than two solutions, or one solution, or no more than some number of solutions, right? So for problem 6, guys, just a remark here, you have to use. I mean, you only have to use the Rolle's theorem. You don't need the IVT for problem number 6. All right. So problem 6, second test. No need for IVT. So no need for the step. No need. No
Professor,
need. Yes.
when you're done, can I ask you? Can you go over 2 more questions?
Oh yeah. Of course. Sure.
Thank you.
Mm-hmm. So yeah. So for problem number 6, no need for the IVT, the intermediate value theorem, the step 1. Right. All you need is the Rolle's theorem, the step 2. We only need Rolle's theorem, right? The step 2. Right. Anyway, so Adrian, you said number 5 and number 7, right? Okay, so sorry. So for problem number 7. So we have this function f. So f of x is x cubed over 3 minus 3x squared plus 5x minus 2. And the interval, of course, is from negative infinity to positive infinity. Anyway, so for the intervals of increase, decrease, well, so we have to, there are 2 steps. So to answer A, intervals of increase and decrease, intervals of increase and decrease. Right, so there are 2 steps. First step, we have to solve f prime of x. So step 1, we have to solve f prime of x equal to 0. And then second step would be to find the chart for the sign of f prime of x. So let's first solve f prime of x equal to 0. So what's f prime of x? So it's x cubed over 3. So here, division by 3, I mean, 3 is a constant, right? Of course, you can, if you want to use the quotient rule, you can use the quotient rule. But actually, you don't really need the quotient rule, because the denominator here is just a constant. And so if you have a constant, guys, just keep it. All right. And you keep the constant and derive the function. All right. So here the function is x cubed. So I'm going to keep the 3 in the bottom. All right. And I'm going to just derive this x cubed. So derivative of x cubed, of course, is 3x squared. Right. So I kept the 3 in the bottom because it's a constant. Just keep the constant and derive the function x cubed. And then minus
Professor,
Yes.
couldn't you also split it up to 1/3 x cubed, or no?
Yeah, you could. Yeah. Sure. You can do that too. You can say, well, x cubed over, yeah. So you're saying you can write x cubed over 3 as like 1/3 times x cubed. That's a good point. So yeah, so it's just it's the same thing, of course, right? So you keep the 1/3, that's your constant, and you derive the x cubed. Absolutely. Next, so we have 3, that's a constant, just keep it. And I'm going to derive the x squared, that's 2x. Plus 5, I'm going to keep it. And derivative of x is 1, so it's like 5 times 1. And minus a constant, of course, is just 0. So f prime of x, cancel out the 3. There's a 3 here. So it's x squared minus 6x plus 5. And of course, I want to solve the derivative equal to 0, right? Because I want to find the intervals of increase and decrease. Derivative equal to 0. This is a quadratic function. So I'm going to use the quadratic formula. So x is minus b. So it's positive 6 plus or minus b squared. That'll be 36 minus 4 times a times c over 2 times 1. So then your x, it's plus or minus. So this is 36 minus 20. So 36 minus 20 would be 16. Square root of 16 is 4. So it's 6 plus or minus 4 over 2. So x 6 plus 4 over 2. You do the top, that's 10 over 2. So then x is 5, or x is 6 minus 4 over 2. So that's 2 over 2. And then that will be 1. Right? So we got 2 solutions, guys. We got this 5 here. We got this 1. And so now I solved my f prime of x equal to 0. Got 2 solutions. Now I can move to the next step. Step number 2, the chart. The chart of f prime of x. Chart of f prime of x. So this is like, so you have your number line. You know, this is negative infinity, this is positive infinity, and on this number line, I'm gonna put the my solutions. So I have positive 1 and positive 5, right? So I'm gonna put my solutions. So here's my positive 1, and here's my positive 5, and then of course I have in the first first row here, that's f of x, and here's my f prime of x in the second row, right? And then of course, so here we have like, you know, 3 different intervals. This is first interval from negative infinity to positive 1, second interval from 1 to positive 5, and third interval from 5 to positive infinity, right? So we have like 3 different intervals, right? So let's say this line here represents positive 1, and this line represents positive 5. Anyway, so now I have to figure out the sign of f prime of x in each interval, right? So the first interval, I'm gonna pick some number, random number. Let's say I'm gonna pick between negative infinity and 1. Let's say just I'm gonna pick 0. Here between 1 and 5, let's pick 2, right? And between 5 and positive infinity, let's pick, for example, 6, right? And I'm gonna plug these numbers in f prime of x, right? F prime of x, my f prime of x was x squared minus 6x plus 5, right? So let me just write down here for you. So this f prime of x is x squared minus 6x plus 5. That's my f prime of x, right? So I'm gonna plug 0 here in f prime. So that's a 0 minus 0 plus 5. That's positive 5. If you plug 2 squared, that's 4, minus 12, that's negative 8, plus 5, that's negative 3. Any question, guys? All right. And then a third interval, I picked 6. So I'm going to plug 6 in f prime of x. So 6 squared, 36. Minus 6 times 6, that's also 36. So 36 minus 36 is 0 plus 5. So it's going to be positive. So here in the third interval, so it's going to be positive. Now, guys, we said, so when the slope or the derivative is positive, the function is increasing. So the function is going to increase on this first interval, right? Then the second interval, the function is decreasing. It's negative. The derivative is negative, so the function is decreasing. And on the third interval, the slope or the derivative is positive, so then the function is going to increase. All right. So to answer the question, the intervals of increase, decrease, right? This is the answer here. So f of x is increasing on the interval. So first on negative infinity to positive 1, union, and then from 5 to positive infinity. And it's decreasing on on the second interval from 1 to positive 5, right? Now, we can also answer the B, the local minimum maximum. So you see here, this positive 1 here, right? This positive 1, you see the function is increasing and then decreasing and then decreases after positive 1, right? So positive 1 would be a local maximum, right? And positive 5, well, the function is decreasing and then it increases just after positive 5. So positive 5 is going to be local. It's going to be local minimum, right? So x equals 1, positive 1 is a local maximum, and x positive 5
Excuse me,
is,
Professor.
yes.
Can you scoot over to the right?
To the right, sure. Like this?
Yes.
I'm going to zoom out. Probably it would be better. Sure.
Okay, thank you. Sorry for interrupting.
Yeah, no problem. So yeah, so that's my local minimum and local maximum, right? Is there any question, guys, about this A and B? I would say for sure. I would say 99.99% you're gonna have similar problem in the final, because this is kind of really important. You need to know how to analyze the functions. You need to know when the function is increasing, decreasing, etc. Local minimum, maximum, they're really important. So this is kind of an important problem, right? Anyway, now the intervals of concavity, and when the function is concave upward, when the function is concave downward, and the inflection point. So this is about the second derivative, right? So this is the answer for A and B. Now for the C. So for the C, this is A and A and B actually. So for the C, the intervals of concavity is that we have to solve. So for concavity and inflection point, so we have to solve first step. So we have to solve the second derivative equal to 0. Right? And then you have to, in the second step, you have to make a chart for f second, right? So first, let's solve f second. So what's f second? Well, f prime. So f prime of x is x squared minus 6x plus 5, right? Now, f second of x. So derivative of x squared, yes.
I have a question.
Yes, please.
Where you say that the interval of
Increase and decrease.
yes, you say f the x is increasing on minus infinity and one union.
Uh-huh.
Instead
Union.
of, because me on the test I didn't put union, I just put and
No, it's fine. It's fine. It's fine. No, it's fine. Yeah, yeah, sure. I mean, you can put and or union. It's fine. Yeah, yeah, sure. Yeah, no problem. Yeah, yeah, sure. Sure. I mean, the union is just another way to say like and, right? It's the same thing. Now, yeah, f second, guys. So this is x squared, derivative of x squared, 2x minus 6. I'm going to keep the 6. That's my constant times x. Derivative of x is 1. So it's 6 times 1. Plus, of course, derivative of 5, which is a constant 0. So f second, it's just 2x minus 6, right? So we have to solve now f second equal to 0. So we have to solve 2x minus 6 equal to 0. Plus 6 both sides. So it's just 2x equal to positive 6. And then, of course, we divide by 2. So divide by 2 both sides. So then x is equal to positive 3. Okay, so we have one solution for f second equal to 0. That's positive 3. So then the second step, we're gonna make the chart. Chart for f second. So step number 2, chart of f second of x. So as usual, so here's my number line going from negative infinity to positive infinity. I'm gonna put my solution, which is positive 3 on this number line. And then I have my f of x in the first row and f second in the second row, right? So then f second, it's actually 2x minus 6. So this is equal to 2x minus 6. So here, guys, in this case, we have just only two intervals, right? So it's from negative infinity to positive 3, and then the second interval from positive 3 to positive infinity, right? Now, let's say this line here represents the number positive 3. Now, pick a random number between negative infinity and 3. Let's just pick 0. It's a very simple number. And from 3 to positive infinity, let's pick 4, for example. So now, if you plug 0 here in the second derivative, of course, you plug 0 in the second derivative, is going to be 2 times 0. 0 minus 6, negative 6. So that's negative. So here on this first interval, your f second is going to be negative. The second interval, we picked 4. If you plug 4 in f second, that's 2 times 4. That's 8 minus 6. That's positive 2. So it's positive number here. All right. Now, so when the derivative is negative, then the function is going to be concave downward. So here the function is concave downward. All right. And if the second derivative is positive, then the function, of course, it's concave upward. Right? This is upward, concave upward, right? And of course, when at positive phi, as this positive phi here, you change the direction of concavity. You go from concave downward to concave upward. So you change the direction of concavity. So your positive phi is an inflection point, right? So to answer the question first, so f of x is concave downward on negative infinity, positive phi, concave upward on phi positive infinity. And we said change the direction of concavity. You go from downward to upward at positive phi. So this positive phi is an inflection point. So x is equal to positive phi is an inflection point because the second derivative changed its sign at positive phi is an inflection point. All right. Any question, guys, about this, Adrian? I hope this makes sense to you. All right.
No question.
No question. Perfect. Okay. So yeah, sure, Adrian, you're welcome. Sure, no problem. Teisha, you said you had a request, right?
Yes. So can you go over problem 1 from the test 2
Uh-huh. Right. Okay. Sure.
and problem 3?
Problem 1 and 3.
Problem 3. Yeah.
Okay. I can probably start. Let's start with problem 3. Okay, problem number 3. So problem number 3. This is again from the second test. So guys, after the second test, I'm gonna talk a little bit about the first test because it's a part of the final, right? So I'm gonna talk a little bit about the first test, and I'm gonna do probably one exercise or one problem about the integrals, right? So problem 3. So in this problem 3, you have to find the critical numbers of the function, right? So the critical numbers, guys, that's the solutions of f prime of x equal to 0. So critical numbers. So what do I mean by critical numbers? Well, critical numbers are solutions of f prime of x equal to 0. So all you have to do, guys, you have to solve f prime of x equal to 0. Okay, and the solutions are the critical numbers. So let's compute this f prime of x. So f prime of x. Well, so we have, again, it's x cubed over 3, right? So this over 3. Well, I can probably write it. I'm gonna write down the f of x. So f of x, it's x cubed over 3. I'm gonna write x cubed over 3 as Daniel suggested. So it's 1/3 times x cubed, right? That's the same thing as x cubed over 3. That's the same thing, right? Minus, and the 5x squared over 2, I can write it like 5/2 times x squared, right? It's just the same thing, plus 4x. Okay, so if you compute f prime, so you want to compute f prime. So this is 1/3 times x cubed. So you just keep the 1/3. That's your constant. So you keep the 1/3, and you derive the x cubed. So derivative of x cubed, of course, is a 3x squared minus the same thing, a 5/2 times x squared. Keep the 5/2 and derive the x squared. So it's 2x plus 4. That's a constant. Keep the constant 4 times derivative of x. It's 1. So f prime of x, we can simplify, right? Because here there's this 3 in the top. This is in the top, and this is in the bottom. This is in the top. This is in the bottom. So we cancel out. So it's just x squared minus 5x plus 4 equal to 0. All right, so we have to solve this f prime of x equal to 0. This is a quadratic equation as usual. So it's just minus b, so positive 5 plus or minus square root of b squared. So square root of 25 minus 4 times a times c, the whole thing times over 2 times a. All right, so it's 5 plus or minus. So 24 minus 16, that's 9. Square root of 9, it's 3. So it's plus or minus 3 over 2. The whole thing over 2. So your x is 5 plus 3 over 2. That's 8 over 2. That's 4. That's the first critical number. And the second critical number is 5 minus 3 over 2. That's 2 over 2. And that's equal to 1. Okay, so we have two critical numbers, positive 4 and positive 1. So the answer, yes, please.
Isn't that 25 minus 16?
Yes, that's 25 minus 16, it's 9.
It's 8.
And then you have to take square root, right? Square root of 9 is 3.
No, I'm saying 25 minus 16 is 8.
Nope, so 25 minus 16 is 9.
It
You
definitely
know,
is 9.
16 plus 9. I mean, you need 4 to make it to 20, and then you need another 5 to make it to 25, right? So that's 4
No,
plus 5.
you're right.
That's,
It is 9.
Yeah, it is.
yeah, it's 9. Yeah.
I'm sorry. I was over here confusing
No
myself.
problem. I mean,
I'm
it
sorry.
happens. No problem. It happens sometimes. Yeah, I know. And I mean, usually, in the I would say 99% of most of the time, in the test or in the final, if you have to solve like a quadratic equation or something, then you should expect to get a whole number, right? Perfect square. If you don't get the perfect square, a whole number, like you get like some square root, some weird square root, then probably you made a mistake, right? So I'm just saying, guys. So in the final, you should expect to have like whole numbers and perfect squares. Okay, so anyway, yeah. Yeah, so to answer, to answer the question, so critical numbers are 4 and positive 1, or positive 1 and positive 4. Okay. All right, so Tasha, you asked, so this is a problem number 3, and you asked about the problem number 1. Okay, so let's move to the problem number 1 then, unless there's a question or, okay, so let's move to number 1. Well, so yeah, this is another important, actually, I would say, subject, the implicit differentiation. So y is equal to y of x. So it's just it's a function of x. So again, guys, you think of y here, it's a function of x. It's like saying f of x. So this y of x is like f of x. It's just a function, right? So, and we want to find the derivative of this function y. Right, so yeah, you have this so this relation between x and y, x squared times y squared plus 2x cosine of y equals to 1. Right, and we're going to use the derivative. So first we have this x squared times y squared, right? And this is a product. It's a multiplication, so it's a product. So we have to use the product rule. Which is, so if you say this is f, this is g, so then it should be f prime times g plus f g prime. Okay, again, this is supposed to be f, and this is supposed to be g. So what's f? So it's f prime times g plus f g prime. So f prime, derivative of x squared, it's 2x times g, right? This is f prime times g. G is y squared plus f, which is x squared, times the g prime. Okay, so now the question is, what's the derivative of y squared? This is y. This y squared is like f squared, so it's like some function to the power 2, right? So what's the derivative of a function to the power 2? So let's say you have a function f to the power n. So what's the derivative of a function f to the power n? Well, we had our rule, which says that the derivative of f to the power n, it's n f prime f to the power n minus 1. Right? So derivative of y squared should be n, so it should be 2. My n is equal to 2, right? The power exponent is 2. 2 times, so it's n f prime. Here I don't have f, I have y, right? Anyway, y or f, both are functions, right? So it's y prime, and then f to the power n minus 1, so it's y to the power 2 minus 1. So it's just 1, so it's just y. So derivative of y squared, it's 2y prime y. All right, so that's the derivative of the first term, the x squared times y squared, plus now the second term here. We have this 2x times cosine of y. So it's a multiplication, right? This is a product. We have a multiplication here. So it's a product. So we're going to use, again, the product rule. Product rule. Now, the 2 here, this is a constant, and we can just keep the constant, right? So we don't really worry about the constant, right? So we can just keep it. Now I have my f is x, and my g would be the cosine of y, right? So we need f prime g plus f g prime, right? So I have this constant 2, so plus 2 times. So f prime. So what's f prime? F is x. Derivative of x is 1. So it's 1 times g. G is cosine of y, plus f, which is x, times g prime. So now the question, guys, what's the derivative of cosine of y? If it was cosine of x, derivative of cosine of x would be just a minus sine of x, right? But this is not cosine of a variable x. This is cosine of the function y, right? It's cosine of some function, of the function y. So it's composition of 2 functions, right? Cosine of y, so f of g, right? So cosine of y, it's a composition of 2 functions. So this is composition of 2 functions, right? You have the cosine, that's the first function, of y, that's my second function, right? Cosine of y. Now, derivative of composition of 2 functions, we have to use the chain rule, right? So then we have to use the chain rule. Right? So I'm going to use the chain rule for cosine of y. So what's the chain rule? Well, let's say I'm going to use a different color. So let's say this is f. F is cosine, f of g. The g is y. So then the chain rule would be g prime, f prime of g. Right? So g is y. So then g prime would be just y prime. F prime. What's f? F is cosine, right? I'm talking about the red f, right? The red f is cosine. So then f prime would be minus sine. Minus sine of what? Well, minus sine of g. So it's minus sine of y. So y prime times minus sine of g. So this is here minus sine of g, which is y. So minus sine of y. All right? Equals to, of course, 1. Derivative of 1 is just 0. So what we are saying, guys, is that, so we have, let me write it down here again. So it's 2x y squared plus x squared times 2 y prime y plus 2 times cosine of y. And there is this minus this minus this one here, minus 2x y prime sine of y equal to 0. Okay. So now, of course, I have to solve for y prime. Solve for y prime. Right? So where's y prime? I have y prime here in this term and y prime in this term. So I have to move all the y, I have to keep the y primes on the same side and move everything else to the other side. So why do we do that? Because once you have all the y primes on the same side and everything else to the other side, then you can, then y prime would be a common factor and you can factor out y prime. So I'm gonna keep the y prime on the left side and I'm gonna move everything else. So I'm gonna move this and the 2 cosine of y to the other side, right? So we have x squared times 2 y prime y, and then minus 2x y prime sine of y. Now, if you move this 2xy squared to the other side, that'll be minus 2xy squared. And if you move this 2 cosine of y to the other side, so that will be minus 2 cosine of y, right? Now, left side, I have my y primes, only my y prime, so then y prime would be common factor. So I can factor out the y prime, right? There's a y prime here and this y prime here, so I can factor out these y primes. And so that will be y prime. And then there's an x squared times 2 times y, and there's this minus. Now, if you pull out this y prime, you are left with the 2x and the sine of y, right? And the whole thing equal to minus 2xy squared minus 2 cosine of y, right? And so now I can divide by this whole thing here, x squared times 2 times y minus 2x sine of y, and do the same, of course, on the other side, x squared times 2y minus 2x sine of y. Right? So that's because this thing here would cancel out because it's the same thing. When you divide by the same thing, then you're gonna get 1. So it's y prime times 1. So it's just y prime. So so the answer, so y prime would be equal to minus 2x y squared minus 2 cosine of y over the x squared times 2 times y minus the 2x sine of y. You can actually you can you know, simplify 2 because 2 is a common factor in the top and in the bottom, right? You can factor out the 2. I mean, this is, I mean, if you get this answer, of course, you get full credit. But as I said, you can also simplify by factoring out the 2. So you know, there's this 2 here in the top and in the bottom. So then y prime would be just, you know, minus x y squared minus cosine of y over, and then x squared times y minus x sine of y. All right, and this would be actually the final answer.
Professor,
Yes.
um, I had the first answer, the one you have with the 2.
Yeah, it's fine. If
Yeah,
you do. Mhm.
and then I made a mistake to write down the second one when I factorized by 2. I simplified the 2 instead of writing down minus cosinus of y. I write down x inside, like on the
You
top.
mean you made a mistake because like just a typo, or because you had the wrong derivative?
No, no,
Well,
no.
it depends.
I have everything right, but instead of you see where you said to factorize by 2,
Yeah. Mm-hmm.
I have all of this like the same,
Mm-hmm.
but in the bottom when I factorize instead of writing minus cosinus of y,
Mm-hmm.
I I missed instead of writing y I write x.
X.
Yeah,
It's fine. It's fine. I mean, if in the previous line, I mean, previous steps, you always had the cosine of y, then it's fine. I mean, yeah, of course, you will get full credit, no problem. Sure,
okay.
that's not a problem. Yeah, yeah, sure. I mean, if you guys, I mean, if you do minor mistake, I mean, it happens to everyone, right? So you will get the full credit. If all your steps, you follow the steps, you get everything correct, and even if you made a minor mistake, that's not a problem. You would get the full credit.
Professor,
Yes.
I made a mistake too in that problem. Like I
Mm-hmm.
don't know what was I doing, but with my calculations, I got y prime, my y prime equal to negative 2x y squared minus 2 cosine y
Mm-hmm.
divided by 2x squared y minus 2x sine y.
Yeah, that's correct. That's correct. That's the right
No,
answer.
that's wrong, right?
In the
Hold
top,
on.
what did you get in the top?
Hold on, let me click up. The I got the same exact answer of that's on the top of the negative 2x y squared minus
Mm-hmm.
2 cosine y, but my
Okay.
bottom I
Mm-hmm.
did wrong because my bottom is 2x squared y minus 2x sine y.
That's exactly what I have here, right? This is you said x squared 2y minus 2x sine y, right?
No, I got all of that, but except for you see your x squared 2y, I got a
Uh-huh.
2 in front of that. I have 2x squared and then a y.
No, that's the same thing. That's the same thing.
It is?
Yeah, of course, because x squared times 2 times, I mean, it's a multiplication, it's a product. So when you say x squared times 2 times y, it's the same thing as 2 times x squared times y. Yeah, it's the same thing, absolutely, yeah.
Oh, okay, okay. Oh, thank you.
It's a multiplication. It's like saying 5
Yeah, I
times
thought I
2.
did a wrong step. I'm
No,
like,
no,
what
no,
step
it's
did I
no,
do wrong?
no. It's your answer is correct.
Okay, thank
It's again, it's just because it's a multiplication, right? When you say x squared times 2 times y, it's like saying 5 times 3 times 4. That's the same thing as 4 times 3 times 5. I mean, the you can change the order of the if you have a multiplication, right? You
yeah.
can change the order of the numbers. It doesn't. You're gonna get the same thing.
Oh,
Sure.
okay. Thank you
Yeah,
so much.
yeah. Mm-hmm. Sure. Um. Any other question, guys?
Yeah, problem 2. I did problem 2, but I want to make sure if it's correct or not. I got it.
The problem too? Yeah,
Yeah.
sure, I can do that. All right, so let me go over problem two then. Sorry, this is all right. So I'm sorry about this line here. All right. Okay, so I'm gonna go over number two. So I mean, problem two is the same idea, but probably derivative here is easier to compute. I mean, we have y squared plus xy plus x squared minus x equal to 2, right? That's our curve. Now, so first step, we said we have to compute y prime. We have to find y prime, have to find the derivative, find y prime of x. Okay, so, well, it's implicit differentiation, derivative of y squared, use, again, it's like f to the power n prime. So it's n f prime f to the power n minus 1. F to the power n minus 1. So derivative of y squared would be 2y prime plus, now x times y, that's a product, so we have to use a product rule. The product rule, right? So x, derivative of x is 1 times y plus x times derivative of y. Well, derivative of y is like saying derivative of f. Derivative of f is f prime. So derivative of y is just y prime. So this is y prime. So here I use the product rule. And then plus, there's the x squared. Derivative of x squared is just 2x minus x. Derivative of x is 1, of course. And then the right side is a constant. Derivative of a constant would be just 0. So, so what we have here, guys, is 2y prime plus y plus xy prime plus 2x minus 1 is equal to 0. So I'm going to keep the y primes on the left side. So this is my y prime here. There's a y prime here. So I'm going to keep them on this left side. And I'm going to move everything else, this y and this 2x and 1 to the right side. So we're going to have 2y prime plus xy prime. And on the other side, so I have to move this y to the other side. So it's plus y on the left. So on the right side, it will be minus y. Plus 2x here. If you move it to the right side, it will be minus 2x. And then minus 1, right side, gonna be the opposite. So it's going to be plus 1. Now, on the left side, I can factor out the y prime. So here's my y prime times 2y plus x equals to this minus y plus 2x plus 1. And I'm going to divide, of course, by this 2y plus x. So 2y plus x. All right. So then this thing here cancel out. And so y prime, the derivative of my function is actually of the slope of my function. So y prime is equal to minus y minus 2x plus 1 over 2y plus x. So that's the first step. First step, you have to find y prime. Now, second step, we can compute the equation of the tangent line. So step 2, equation of the tangent line. So for the equation of the tangent line, guys, I'm going to just first remind you the formula of the equation of the tangent line. Of tangent line at the point, let's say a f of a, tangent line. So the equation is the following. So y, so the equation of the, so the equation of the tangent line is y equal to f prime of a x minus a plus f of a. Right? This is the general formula. I mean, this is the formula for the equation of the tangent line to the function f, or at the point a f of a. Right? So what's our point? Our point is 2, 0. So this point here, a f of a, this is the point 2, 0. Right? So like it's like saying a is 2 and f of a is 0. Okay, so this a is 2 and this f of a is 0. So then we have y equals to f prime of a. We don't know yet what's f prime of a. X minus a. A is f prime of course. A is 2. So this is x minus 2. This is of course f prime of a. A is 2. So this is f prime of. We need f prime of 2 plus f of a. F of a is 0. Right. Now the question is, the only thing missing here is the f prime of 2. And to find this f prime of 2, we're going to use the first step. So, so you want to find this f prime of 2, right? So we're going to use the first step. So in step 1, so you have your y prime. That's the derivative of your function. Y prime is like f prime, right? So this f prime of 2, so y prime is equal to, so a is like your x coordinate, right? This is, this 2 here, this is like x coordinate, and this is like the y coordinate. So what we are saying is like x is equal to 2 and y is equal to 0. Okay, so I'm gonna plug 2 and 0 in the y prime. So we have, y prime is supposed to be minus y minus 2x plus 1 over 2y plus x. And what we are saying is that x is equal to 2, right? That's your x coordinate, that's your a. X is equal to 2, and y, which is the y coordinate, or f of a, that's the 0. So if x is 2 and y is 0, so let's find out what's a y prime. Okay, so what's y prime? Well, y prime would be equal, in that case, minus 0 minus 2 times 2 plus 1 over 2 times 0 plus 2. So in the top, we're going to have negative 4 plus 1 over 0 plus 2. It's 2. So y prime is equal to negative 3 over 2. Okay, so what we are saying, guys, is that this, you see this f prime of 2 in the equation of the tangent line, that's equal to negative 3 over 2. Okay. So to answer the question, so answer the equation of the tangent line to this curve at the point 2, 0 would be y equals to negative 3 over 2 times x minus 2 plus 0. So that will be equal to, so y, so that's the negative 3 halves times x. This is a multiplication, of course. So minus minus would be a plus. 2 over 2 cancel out, so it's just a plus 3, right? When you multiply this by this negative 2, that will be positive 3 because the 2 cancel out. So this is here, this is a fine answer. This should be your answer. That's the equation of the tangent line to the curve at the point 2, 0.
Yeah, I got that one wrong, Professor, because I didn't do all of the steps you did. Like my y, I just stopped at the y prime, but my y prime is wrong too. I got minus 2x minus 1 divided by 2y plus xy.
Plus x plus xy. Well, at least do you understand now what's
yeah, I understand now, and I see
where is your mistake?
Yeah, my mistake started like I got everything you have up into right before you I have the 2y prime y plus
Mhm.
plus 1 times xy prime y plus 2x minus 1 equals 0. But after that, I put solve for y prime, and then I did basically when I put solve for y prime after that step, I didn't solve for y prime. I just
Okay.
used the I factor out at the y's. That's what I basically
Oh, okay.
after that step. Yeah.
Okay, so yeah, yeah, of course. So you have to factor out the y prime. That's because you are trying to solve for y prime. Yeah. Well.
But I see now though.
Yeah. Yeah. That's the important thing, right? You learn from your mistakes. That's the important thing. But yeah, this is kind of I would say this implicit differentiation. I would say would have for sure you would have a problem in the final about the implicit differentiation, because this is really important. If you take Calc 2 or Calc 3, then this you will use this implicit differentiation a lot. So yeah.
Thank you, Professor.
Sure. All right. Any other question, guys? Any other requests about test number 2? Actually, we did I think we did most of the problems, right? in the test we had 8 problems, right? I think I solved I don't know, probably 5 or 4 or 5 problems. But anyway, guys, do you have any other request or a specific question about the test number 2? Okay, well, there's no question about about the test number 2. So let's take a break of 5 minutes, and then after the break, I'm gonna discuss a little bit the first test, and I'm gonna do one problem about the integrals. All right, so that would be great if you can find your first test. If you during the break, if you can find your first test and check if you have any any question, or if you had any problem with the first test. Okay, so yeah, so please during the break, please try to find in your computer, or I don't know, somewhere your first test. Okay. So let's take a break 5 minutes. I'll be back at 7:35. Right. So break 5 minutes, guys.
Okay, Professor.
Sure. Thank you. So be back at 7:35. All right, guys, I'm back. So, okay, so let me just check our first test. So first test, first problem. So the first problem was about the limits. So you need to know. I guess you're gonna probably have a problem about the limits because you know, as you see, I mean, everything is about limits, right? The derivative, it's about limits. The integral, it's also a limit. So you need to know how to compute the limits. This is like the basic, the most important and the most basic thing you need to know in your calc class, right? So you're probably gonna have to compute some limits. So it would be a good idea if you, I don't know, I mean, if you had any trouble with the problem number 1 in the first test. So again, it's about the limits, computing the limits. So I see here, well, there are different kind of limits. X going, so let me just remind you, so when you have x going to infinity, guys, so this is about the first test, test number 1. Of course, please let me know, guys. I mean, if you have any question about the first test, right? So, but let me just remind you, for the limits, first, when you have x going to infinity, so for example, let's say you want to compute limit x going to positive infinity of some rational function, for example, x fourth minus x cubed minus 2x over, let's say, negative 5 x fourth minus 2x cubed plus 1, for example, right? So whenever you have x going to infinity, okay, so if you have x going to infinity, either plus or minus infinity, it doesn't matter, right? If you have x going to infinity and you have some rational function, what I mean by rational function is a quotient of polynomials, right? So you have a quotient here, quotient of polynomials. Then actually, guys, all you have to do is to apply the following rule. So you can just apply, then we can apply the following rule. So you have to compare the degrees of the two polynomials. So you have to compare the highest power of x in the top with the highest power of x in the bottom, right? So the rule says the following, you guys. So in this case, again, you need your x to go to infinity. If your x doesn't go to infinity, you cannot apply this rule, okay? So this is only when x going to infinity and you have some rational function. So then you can apply the following rule. So if the degree in the top, so degree, what do I mean by degree? Degree, that's the highest power of x, okay? Instead of saying highest power of x, I'm gonna just say degree. So when I say degree, I mean the highest power of x. So if the degree of the top, if the highest power of x in the top is larger than the degree of the bottom, the highest power of x in the bottom, okay, then the limit would be equal to infinity. Right? If the degree of the top is less than the degree of the bottom, okay, then the limit is just 0. Okay. Now, if I'm going to just zoom out. Yeah, then if the degree or the highest power of x in the top is equal, like in this example, right? The degree of the top is 4, degree of the bottom is 4. So if the degree of the top is equal to the degree of the bottom, okay, then the limit would be equal to the ratio of the leading coefficient. So the leading coefficient in the top. So what do I mean by the leading coefficient? That's the coefficient of the highest power of x over the leading coefficient in the bottom. So like in this example, the leading coefficient, so as I said here, the degree is 4. In the bottom, the degree is also 4, so they are equal. So we are in this the third case, right? So then, limit would be the leading coefficient of the top. So leading coefficient is of the top, that's 1, because we have 1 times x fourth. And the leading coefficient in the bottom, that's the -5. Right? So the answer to this question would be, so then this limit is actually equal to 1 over -5. Okay. Again, this is when the highest power in the top is equal to the highest power of x in the bottom, right? And again, guys, you can only apply this rule when your x is going to infinity. If x doesn't go to infinity, you cannot, we cannot apply this rule, okay? So for example, let's say, so this is my first example, example number 2. Now let's say you have limit x going to 1, and let's say in the top I have x squared minus 5x plus 4 over x squared minus 3x plus 2. All right, so here, guys, my x is going doesn't approach infinity. It approaches 1, right? So this one here, this is a finite number, right? So in this case, I cannot apply the rule we had here, right? So what do we do in this case? Well, it's general rule of thumb. First step when you compute a limit is you just substitute x by the number given in the limit. So here x is going to 1. So first step, it's just you have to replace your x by 1. All right, so if you replace x by 1, of course, here that will be 1 minus 5 plus 4 over 1 minus 3 plus 2. And that will be 0 over 0. But then 0 over 0 is indeterminate form, right? So 0 over 0, this is indeterminate form. So 0 over 0, this is indeterminate form. And so we have to find another way to compute this limit, indeterminate form. Now, what would be that way? Well, here in this case, when you have polynomials, you have to, if you get 0 over 0, you have to factor the top and the bottom. So the idea here would be to factor the top and the bottom, because when you replace x by 1, you get 0. It means that x minus 1 is a factor. So factor the top and the bottom by x. So we have to factor the top and the bottom, and actually x minus 1 is a factor. Okay. So like here in the top, I have, so limit x going to 1. So I have this x squared minus 5x plus 4 over x squared minus 3x plus 2. And what I'm saying, guys, is that, so you have to factor out x minus 1 in the top and also x minus 1 in the bottom. So x minus 1, you have x squared. So to get x squared, I have to multiply x by x, right? That will be x squared. And to get this plus 4, I have to multiply this -1 by minus 4, right? -1 times -4, that would be the +4. In the bottom, I have x squared, so I have to multiply my x by another x here to get this x squared. And to get +2, I have to multiply -1 by -2, right? -1 times -2 is +2. And so you see, then your x minus 1 cancel out. So now it's just limit x going to 1 of x minus 4 over x minus 2. And then now I can just plug x equal to 1 again. So that will be 1 minus 4 over 1 minus 2. That will be -3 over -1. And that will be +3. So the answer is +3. Okay. Anyway, so this is just to remind you guys. So you have to make distinguish between the two cases. So the case when x goes to infinity. So if x goes to infinity and you have a rational function, I mean a quotient of polynomials, you can just apply this rule here. But now if x is going to some number, not infinity, right? Some number, and then the first step would be just to replace x by that number. But here you get 0 over 0, that's indeterminate form, which means that we have to find another way to compute this limit. And in this case, when you have a rational function, we have a polynomial over a polynomial. The idea would be to factor the top and the bottom, right? Anyway, so for the test, for the final, guys, you need to try to review, how we compute the limits, etc. It's gonna be in the test for sure. Yes. Now next, of course, the continuity and the differentiability, right? That's also in the first test. Continuity, differentiability. Let's see what else. Equation of the tangent line. That's we know how to do that. Yes. So basically, there's a continuity and differentiability, right? So let me just do a problem here for the first test, where we have continuity, question about continuity and differentiability, all right? So let me, for example, unless you have a request, I will probably do, let's say, problem number 3, okay? So this is problem number 3 in the first test. So this problem, I mean, this problem covers the continuity and the differentiability. So the problem is the following. So you have this f of x, this function. It's equal to x squared plus 4 if x is strictly less than 1, and 3x plus 2 if x is larger than 1, larger or equal to 1, right? So first question, is f of x continuous at x equal to 1? So question 1. So first, so A is f of x continuous at x equal to 1. All right, so let me just remind you. So what's the definition of continuity? Well, f of x is continuous at x equal to a if the limit of f of x going to a, is equal to f of a. Right, that's the definition of continuity. So f is going to be continuous at x equal to a if the limit of f of x going to a is equal to f of a, right? So there are two things here to compare. We have first the limit of f of x going to a, and then we have f of a. So in our case, we are interested in a equal to 1, right? X is equal to 1, so x equal to a. So my a is 1. Right, in this problem, a is 1. So first I'm going to compute, so step 1, I'm going to compute this limit, So what's this limit of f of x? X going to 1. Okay. Well, what's f of x? X approaching 1. What's f of x? Do I have to use the first equation or the second equation, guys?
The second equation?
Nope. Actually, we have to use both because x is approaching 1. I mean, when you say x approaches 1, it means that actually x approaches 1 from the left and also from the right. Okay, so which means that you see here's 1, and there are two ways to approach 1. You can approach 1 from the left, or you approach 1 from the right. So if you approach 1 from the left, then your x would be less than 1, right? So in this case here, this is less than 1. Right, this is less than 1. And if you approach x 1 from the right, then your x would be larger than 1.
Question.
Mm-hmm.
So when you do, like, say when you do both of the equations and they're both the same number, that means they're continuous at 1, right?
Yes. Mm-hmm. Mm-hmm. So yeah, absolutely. So and again, the thing is, you have to understand what do I mean by this x and arrow 1. So it means that x approaches 1. And when you say x approaches 1, do we mean x is less than 1 or x larger than 1? But the thing is, if you approach from the left, then x would be less than 1. And if you approach from the right of 1, then x would be larger than 1. So here, to compute this limit, or I mean to compute this limit, we have to use the both equations. So first, in the case when x approaches 1 from the left, so I'm going to use minus here to say it's x approaches 1 from the left. So then in this case, x would be less than 1. So in this case, because x approaches 1 from the left, then x is less than 1. All right, so this is limit x going to 1 minus. So f of x when x is less than 1 would be the x squared plus 4. Right, so then you just replace x by 1, of course. So that's 1 squared plus 4, so that would be equal to 5. Right, so this is 1 squared plus 4, and that will be 5. Okay, now if x approaches 1 from the right, so now limit x approaching 1 from the right, 1 plus. So this plus means you approach 1 from the right. Okay, so this is from the right, and this is from the left. So if you approach 1 from the right, then your x would be larger than 1. I mean, x is on the right side of 1, so it's larger than 1. Okay, so if it's x is larger than 1, we have to use the second equation, right? So x going to 1 plus, so x larger than 1, we have to use the equation 3x plus 2. And then you just replace, of course, x by 1. So that's 3 times 1 plus 2. That's equal to 5. So when you approach 1 from the left, you get 5. When you approach 1 from the right, you get 5. So then this limit exists. So the limit of f of x, x approaching 1. So when you write x approaches 1, it means that you are approaching 1 from both sides. So this limit here is the limit from both sides, right? This is from both sides. And so this limit from both sides exists because you get the same number when you approach 1 from the left or from the right. So so this limit is equal to 5, right? Okay. So if the limit from the left, guys, is different from the limit from the right, then this limit from both sides do not exist. Okay, so just to remind you, so if limit from the left is different from the limit from the right, okay, which is not this, which is not our case. In our case, they are equal. From the left and from the right, we get 5, right? Then, but if they are different, then this limit do not exist. So then limit x going to 1 from both sides, this limit do not exist. Do not exist. Okay. So yeah, so that's the limit of f of x, x going to 1 is actually equal to 5. Now, the other thing we have to compute is f of a, right? So we are saying this is equal to 5. Now, what about f of a? Well, or a is 1, right? So what's f of 1? So which equation I'm going to use for f of 1? Well, f of 1, x is equal to 1. Here, you see here x can be equal to 1. So I have to use the second equation because that's where x is equal to 1, right? So to compute f of 1, I have to use the second equation, right? So this is a step number 2. So f of 1 is equal to 3 times 1 plus 2 is equal to 5. So again, I'm using the second equation because your x can be equal to 1, right? In the second equation. So conclusion now, guys, you compare the limit to the limit of f of x, x going to a, to f of a, and they are equal in this case, right? So here we are saying that the limit of f of x, x going to 1, is equal to f of 1. So both are equal to 5, right? So then f of x is continuous. That's the definition of continuity, right? So then f of x is continuous at x equals to 1. So for example, for some reason, this limit of f of x, x going to 1 do not exist. For example, the limit from the left is different from the limit from the right. So then your limit do not exist. So if your limit do not exist, then of course your f of x is not continuous at x equal to 1, right? Yeah, so that's for the continuity. Any question, guys? So this is the first part of the question. Now the second part is about differentiability, right? So let me remind you what's the differentiability. So this is a continuity. Now the second part of the question. So the question is, so this is B, I guess. Is f of x differentiable at x equal to 1? Okay, and you have to find or determine f prime of 1. F prime of 1. Okay. So let me just remind you differentiability. So the definition, so f of x is, so this is the definition. So just to remind you definition. So f of x is differentiable at x equal to a if the number f prime of a, which is if this limit x going to a, sorry, not x, but I'm going to use the h going to 0, of course. So h going to 0 of f of a plus h minus f of a over h if this limit exists. Okay. So the function is differentiable if this limit, if this slope exists. Now, in our case, a is 1, right? In our case, a is 1, so we have to use, so in our case, a is 1, and of course, f of x is this x squared plus 4. If x is less than 1, and 3x plus 2 if x is larger or equal to 1. All right, so we want to compute this f prime of 1, right? We want to see if this, so f prime of 1, a is 1, is equal to limit. This is definition, right? I'm using definition, right? So this is limit h going to 0, f of a plus h, a is 1, so it's 1 plus h minus f of 1 over h. Okay, now, so now the question, guys, of course, is, well, we know f of 1, we said when we check the continuity of f of x, f of 1, we said it's 5, right? We know that f of 1 is 5. Now, the question, or the big, I would say, the big question is, what's f of 1 plus h? Well, so first we have to figure out whether 1 plus h, is it, this 1 plus h here, is it less or larger than 1? Well, you may say, well, 1 plus h is going to be larger than 1 because we have plus h. But the thing is, your h, it can be negative. So imagine if your h is negative, negative 2. So then 1 plus negative 2, that'll be negative 1. So it's going to be less than 1, right? So because your h could be positive or it could be negative, so this 1 plus h, it depends. So it could be larger or less than 1. Depends if h is positive or negative, right? So, so again, the idea is your h is going to 0. So h, so here's 0, and your h is approaching 0. And if h approach 0, so then h could be either negative or positive, right? So if h approaches 0 from the left, then h is going to be negative. And if h approaches 0 from the right, then h is going to be positive. So in this case, if h approaches 0 from the right, so when h is positive, so in this case, 1 plus h, because h is positive, is larger than 1. And in this case, when h approaches 0 from the left, then h is going to be negative. And so 1 plus h is going to be less than 1. Right? And when you are less than 1, you use the first equation. And when you are larger than 1, you use the second equation. All right, so here to compute this limit, there are two cases. Depends on whether h approaches 0 from the left or from the right. So if h approaches 0 from the left, h is going to be negative. So then 1 plus h would be less than 1. So we have to use the first equation. If h approaches 0 from the right, then 1 plus h is going to be larger than 1. So we have to use the second equation. Right. So here, guys, we're gonna have to compute two different limits. So first, limit when h goes to 0 minus, all right, of f of 1 plus h minus f of 1. F of 1, we said it's 5, so minus 5 over h. So here I'm going to use, because h is negative, so 1 plus h is less than 1, so I'm going to use the first equation. So 1 plus h would be f of 1 plus h, so this is limit h going to 0 minus. So f of 1 plus h, I'm going to use the first equation, all right? That will be 1 plus h square plus 4, right? That's like x squared plus 4, but my x is 1 plus h. So 1 plus h squared plus 4, and then minus 5 over h. So let's compute this thing. So 1 plus h squared, you expand the 1 plus h squared. So h going to 0 minus 1 plus h squared. So it's going to be 1 plus h times 1 plus h, right? So it's 1 plus h squared plus 2h. And then there's a plus 4, then it's minus 5, and the whole thing over h. Now, you can see there's this 1 plus 4 minus 5. That's 0. So it's just h squared plus 2h over h. You can factor out h in the top. So the limit h going to 0 minus, factor out h. So it's h plus 2 over h. So then h over h cancel out. And so it's just limit h going to 0 minus of h plus 2. And so your h is equal to 0. So the answer here would be positive 2. Okay. So this is when h goes to 0 minus. So when h approaches 0 from the left, and I have to use the first equation, right? Now the second case, when h approaches 0 from the right, we're gonna use the second equation. So limit now h going to 0 plus. So this is like the slope from the left side. Okay, so this is like this 2. This is the slope from the left side. Now the slope from the right side, again, it's the same, just the same definition, minus 5 over h. And now I'm going to use the second equation. Right, so it's limit h going to 0 plus. So what's f of 1 plus h? So what's the second equation? Second equation is 3x plus 2. Just substitute x by 1 plus h. So it's a 3 times 1 plus h. 3 times 1 plus h plus 2. Right? Then there's this minus 5 over h. So this is equal to limit h going to 0 plus. So 3 times 1 is 3. 3 times h is 3h plus 2 minus 5 over h. So 3 plus 2 minus 5 is going to be 0. So it cancels out. And so it's just 3h over h. So h going to 0 plus 3h over h cancel out. And so it's just 3. So is equal to 3. Right, so this is my slope from the right side. This is the slope from the right side. So this is when h goes to 0 plus. So the slope from the left is positive 2. The slope from the right side is positive 3. So then the slope from both sides do not exist. Right, so the conclusion is that conclusion is limit h going to 0. So this is the slope from both sides. So this is from both sides. So h going to 0 of f of 1 plus h minus f of 1 over 5 over h. So this limit do not exist. So this limit do not exist because the limit from the left when h approaches 0 minus is different from the limit when h approaches 0 plus or h approaches 0 from the right. Okay, so then the limit from both sides do not exist. All right, so one is from the left it's 2 and from the right is 3. So the limit from both sides do not exist. So this slope, this f prime of 1 do not exist. So this f prime of 1, so this f prime of 1 here do not exist. Okay, so f prime of 1 do not exist, limit do not exist, and so f is not differentiable. F of x is not, because it doesn't exist, so it's not differentiable at x equal to 1. X equal to 1. All right, guys. So this is also, I guess, a very important problem. I would say most likely you would have the same problem and a similar problem in the final, because the notion of continuity and differentiability, they are very important, especially if you're gonna take Calc 2 or Calc 3. So yeah, so you need to know what's when a function is continuous and when a function is differentiable. All right. Any so I guess that's the main problems in the first test. It's all about continuity and differentiability. So if you don't have any question, guys, or a specific request, I would probably now do a problem about the integrals. So this is similar to the problem number 2 in the homework 10. So okay, so we're gonna do a problem. Just do problem about integrals. So just remind you the homework number 10. So it's due this Monday, right? So so this is similar to the problem 2 in homework 10. Problem 2 in homework 10. Okay, so you need to know how to compute these integrals, right? The antiderivatives. So just to remind you some rules, right? How to compute the antiderivative or the integral. For example, if you have x to the power n, then the antiderivative or the integral. So probably I can use the integral here. So integral or antiderivative of x to the power n, that will be x to the power n plus 1 over n plus 1 plus some constant. For example, if you have exponential, right? This is a dx, of course, here, so dx. So integral or antiderivative of e to the x is also e to the x plus some constant, etc. Anyway, you can find all these rules in the lecture of last week. So, for example, let's do an example. Example. So let's say you want to compute integral of, let's say, x fifth minus 4 x cubed, right? Dx. And let's say here the bounds are, here it's 1, and here, or let's say, yeah, 1, and here it's 2. Okay, or let's say it's a 0 and 1 instead of 1 and 2. I'm gonna just take instead of 1, 2, I'm gonna take here 0 and 1. All right, so you want to compute this definite integral. So let me just remind you guys the interpretation of this definite integral. So what's the geometric interpretation of this integral? So it's just you know, you take this function f of x. So here's your function f of x. This is f of x, right? That's your function f of x from 0 to 1. So here's 0, here's 1, and you have some function f from 0 to 1. Let's say this is my function f of x. This is my f of x, right? This function here. And then, so this definite integral would actually would represent the area of this region, which is bounded by the graph of f of x and the interval 0, 1, right? This is, so again, the idea is that this would be the area, this area here of this, the area of this region here. All right. So that's the interpretation of this definite integral. Anyway, so you want to compute this area or this definite integral. First, I have this, here's x fifth minus 4x cubed. So we said if you have a minus or a plus, so then you can split this integral into two integrals. So you can have integral of x fifth minus the integral of 4x cubed. Okay. So you start with the x fifth. What's the antiderivative or the integral of x to the power 5? So this is like saying the integral of x to the power n. So if you have x to the power n, the integral. So here again, guys, we're not talking about the derivative. Derivative of x to the power n would be n x to the power n minus 1. So here we're talking about the integral or the antiderivative. So the integral of x to the power n, that's x to the power n plus 1. So you have to increase the power by 1 over n plus 1, right? So your n here is 5. All right, this is your n. So, so the antiderivative of this x to the power 5 is x to the power 6 over, or x to the power 5 plus 1 over 5 plus 1, right? Anyway, so remember, this definite integral would be the antiderivative of x to the power 5 at 1 minus the antiderivative of x to the power 5 at 0, right? And then, of course, there's this minus, okay, minus, there's this minus here. Okay, there's this minus. And then we said, so this is the integral of 4x cubed. So we said if you have a constant inside your integral, then you can move this constant outside the integral. So we have 4x cubed, so you can just pull out the 4 outside the integral. So this is like minus 4 integral of 0, 1 integral of x cubed dx. Right? So this capital F here, guys, this is so this capital F of x, this is the antiderivative of x fifth, right? So this is x power 5 plus 1 over 5 plus 1 plus the constant. We're supposed to have a constant, but it doesn't really matter, the constant, because when you take the difference between f of 1 and f of 0, the constant will just cancel out. All right, so then, and then there is this integral of x cubed. Well, integral of x cubed, so this is actually equal. Well, first, f of 1 minus f of 0, so you plug 1 here. That's 1 power 6 over 6 plus c minus, and now you replace x by 0, so it's a 0 power 6 over 6 plus c, okay, minus 4. Now the antiderivative of x cubed, right? So minus 4 antiderivative. So here I'm going to put f of 1 minus f of 0. So where f of x here, this is the antiderivative of x cubed. So antiderivative of x cubed, it's x to the power n plus 1. So it's x to the power 3 plus 1. So it's x to the power 3 plus 1 over 3 plus 1 plus this constant c. Right, so then, so we're going to have, so this is equal to, so 1 power 6 is 1 over 6 plus this constant minus 0 over 6 plus this constant c minus 4. And now I'm going to plug 1 here. All right, so that's 1 to the power 4 over 4 plus c minus, and then I'm going to plug 0. So it's 0 power 4 over 4. There's plus c, right? So plus the parentheses here, we're supposed to have parentheses plus c. Right? So anyway, the c, they're going to cancel out. It's not a problem here. So it's this, this c here minus c, they cancel out. And there's this c here minus this c, there's just 0. So we're going to end up with, there's 1 over 6 minus 0 over 6 minus 4 times 1/4 minus 0 over 4. So it's just 0 over 6, of course, is just 0. So this is just, this is just 0. and this is 0 over 4 is just 0. So we're going to have 1 over 6 minus 4 times 1/4. So then 4 over 4 cancel out. So it's 1 over 6 minus 1. 1 over 6 minus 1. And so common denominator, of course, multiplied by 6 in the top and in the bottom. So it's 1 over 6 minus 6 over 6. So 1 minus 6, the top, it's minus 5 or negative 5 over 6, right? And that will be a fine answer. So it's negative 5 over 6. All right, so again, guys, all you have to do here is to find this antiderivative. And once you have the antiderivative, you have to plug the bounds. Like here, I had, I had 0 and 1. So then I have to plug the 0 and 1 in the antiderivative, right? And of course, you have to take the difference. It's a minus, right? Yeah, so anyway, I don't know if you have any question about this, guys. Again, this is similar to the problem 2 in the homework 10. And in the final, you're gonna have a similar problem, okay? Because you need to know how to compute these integrals, right? Any question, guys, about this problem, integrals?
No.
No. All right. So yeah. So I guess. All right. So I guess we did the second test. We discussed the first test. All right. And also this integrals. So
Professor, can you go to the right?
yeah, sure.
Yeah.
Here.
Thank you.
You're welcome. All right, guys. I think I went over everything I want to do. So probably, I mean, if there's no question or request, I'm gonna probably stop here. So I'm gonna wish you good luck, of course, next Wednesday and the other exams too. And wish you happy holidays, of course. And I hope I'm gonna see you around in campus next year. Probably not next spring. I would say next spring we're gonna also go online. But I hope I will see you next year in the campus.
Okay, Professor.
Anyway, so yeah, I'm gonna stop here, guys. Thank you everyone. And of course, if you have any question, anything, any question about the final, just email me. All right. Thank you, everyone, and good night.
Thank you,
And good luck.
Professor.
Thank you,
was an
Whitney.
awesome professor, despite COVID and having to do it online. You taught
Yeah.
very well and helped me learn. So
Thank you, Juanita. I appreciate.
You're
Thank you,
welcome.
Juanita. Thank you, everyone, and good luck.
Professors,
Holidays.
enjoy your
Happy-
holidays.
Happy holidays, Whitney. Enjoy your holidays, and good luck in the final.
Yes, thank you.
Wish you the best of luck. Thank you,
Okay.
everyone.
Thank you.
Good night.
Good night.
Take care.
Thank you,
And stay
Professor.
safe.
Have a good night.
Thank you.